let's go.
Hey guys, I'm Nick, and here's a little bonus update for the latest particle flow on Surface. Today I will show you an alternative way using volume fluids and view pop forces. Alright, so as you can see, it's all pretty default here for our setup. I'm using one RS slide, which is somewhere very far. It's here. I'm using second camera. We don't need that because it's like for the preview purposes or for close-up shots. Yeah, so for now, just this little setup. And for the materials, as you probably already know, I'm getting the color data. Let me open up the CD from the particles. It goes into the diffuse color, roughness is pretty high, and that goes to the redshift material. Then all of that is fed here in the material. And obviously, because it's a particle system, we go to the redshift, particles, render objects as particles, and global scale multiplier set to 1. Alright, now let's go and check out what do we have here. So, not that neatly organized, but I think for this quick little tutorial, let's just do it as it is, because I wanted to release it right after our first initial flow on Surface tutorial. So what do we have here? We start with a sphere, and this works for any sort of geometry, and radius is set to 0.5, frequency is set to 64, so it's really quite a dense mesh here. So then what I need to do is create a layer of particles. And how I can do that? So we will use labs thicken node, which is absolute equivalent to poly extrude. It's just like less buttons. If you don't see labs thicken in your labs, here you can see labs and all that stuff. You have two options. Either install labs, which is super easy from the Houdini launcher, just download SideFX launcher from the official website, or you can use poly extrude. Here I am extruding our sphere to 0.015, minus 0.015. So what it means that I have a really thin layer. I can show you if we go to the wireframe mode. You'll probably see this very thin layer of reverse extrusion. So now let's get back to smooth shaded and reverse it. And of course, this is because we have our light here. Let me go to the lights and enable in viewports. Let's turn it off. Let's go back to our geo. So we have our reverse, and now we drop grain source. So before I enable that, two things. I have to reset my start frame, and here you can see that I'm using 0.006, which will take quite a lot of time to simulate, actually less than 10 minutes, but like in the time frame of this tutorial. Let's say we want to do something real fast, so let's say 0.01. So jitter scale is checked and random value set to 0.3, and if I view our grain source, you can see that it will calculate it just a bit, and you see we have all of that as a volume of particles. But we just want a thin layer, so what we can do is drop group type set to points, and keep in bounding regions is enabled, and bounding type should be bounding object, and we plug our initial sphere into the second input of the group node, and here we have. So we select everything what's inside, and because we use the thicken, we actually added a bit of thickness, so the outer layers. So if we go and drop a delete node, and here we say group 1 and entity points, so we delete everything that's inside, we have this thin layer. Now we want to drop a volume fluid, and obviously into the left input we plug our delete, and into the right input, which is collisions, we plug our sphere. In my case, I have made it smaller just a bit. You can skip this part if you don't want to resize it, but I wanted the particles to kind of drop on the surface. It is basically the same effect, so yeah, we can even remove this transform and just plug directly. So for the volume fluid, what we are doing here, we uncheck create points from volume, we uncheck particle size, and then you can play with these settings more to get really different results. But the main thing is viscosity, just a bit of viscosity, so it's 10, surface tension and repulsion, which should be 0. And for my convenience, I unchecked display as spheres, because if we go display as spheres and we are using 0.006 as our point separation grain source, the viewport is pretty laggy. So what I'm doing, I'm just like adding the sprite material, which is less resource heavy. And then we drop a vellum solver. So quite a few things here. For the solver, substeps surprisingly 1, and it works. So for the forces, removing all the gravity, we don't want that. For the simulation, advanced, in grain collisions, assume uniform radius should be unchecked. And for the visualized, I tend to just uncheck the show collisions, so we don't have this ugly blue something. Yeah, this one, we don't want that. So now let's dive inside and see what actual forces will be used to drive our simulation. So from the previous tutorial, you probably know that we will be using curl noise. Here, noise type original Perlin noise, frequency 0.41.6, and that's for that, you know, more like horizontal waves or vertical waves. I'm also using time for the offset, so we don't have our noise strictly like uniform. It will be flowing on the surface in time. And then we get our noise and plug that not into the force, but into the velocity. So then, let me go back. We have a pop axis force, and here I'm setting orbit speed to 4. And that's basically it. The magic part is here in the subsolver, but first of all, let me just bypass the subsolver and let me show you what we are getting right now. So as you can see, even at frame 60, everything is just like blowing away and not sticking to our surface. Here we actually have a few options, right? So for the sphere, what we can do is add pop attract. And because our sphere is positioned exactly at the center of all axes, we can add a bit of force. Let's say, let's try 2, and let's resimulate that to the frame 60. So here you can see that nothing actually changed. Guess why it wasn't working? Because pop attract wasn't even plugged. Let me resimulate that. And now you see that pop attract is working correctly, and we can control quite a few things here. We can decrease the amplitude of the pop wop noise. Here in the curl noise, we can decrease the amplitude. We can make the, by the way, it looks quite cool though. We can increase the force scale of our pop attract. It will be working absolutely fine. And on top of that, I think if we actually simulate the 0.006 actually, it will look really cool. But there's another thing that we can try and do. I will leave the pop attract here, but just bypass it for now. And here you can see we have a subsolver here connected to our source input, and let's enable that and dive inside. So what we have here is the ray sub, which actually can project one geometry onto another one. So we grab our dop geometry, which is our particles, and we plug it into the left input of the ray sub, and we grab our object merge, which is now is pointing to the transform 1, and transform 1 actually, it was here, but we have deleted it. So let's grab our initial sphere, I assume. So let's go here into vellum solver, into subsolver, and here we definitely want our sphere 1, where it is, sphere 3. Yep, it's sphere 3. So let's go here again, vellum subsolver, sphere 3. So now the thing here with the ray sub, we should change the method to minimum distance, and this scale you can basically control how much of a ray sub should influence our particles. So right now it's set to 0.1, and let's simulate till the frame 60. So here you can see that we still stay on the surface with a slight offset. I would say that we are staying like 70% on the surface, and that's when our pop attract is turned off. Let's go back to the subsolver, and for the ray sub here, let's increase this to 0.5, and let's simulate these 60 frames. Now you see when I up the scale to 0.5, I would say we are kind of like 90% on the surface. that looks also really cool. You can also try something that I have never actually tried, but let's say 0.03. I don't know what the result will be. Alright, so actually 0.03 wasn't working, somehow it was getting me an error, but 0.04 is also crazy cool. So look at that, look at that. We have like, I don't know, crazy deformations here, but we still stay kinda on the sphere. Let's bring it back to the 0.1. That's basically it for this subsolver. So we can file cache our, in my case, 120 frames. And let me show you what I got. And here you can see how it actually performs with this level of noise and with this amount of particles. For the particles, actually not quite that much, 259,000 particles. So now what I want to do is colorize them, and for this one I want to make kind of same thing that we did for this rectangle surface flow, which is particles that are at the floor, at the bottom of our volume, had one color, and that color was in a gradient till the particles that were up on top of our volume. For this one, I want to get a distance of particles, of each particle actually, from the center to its current position. So here I'm using, actually wanted the y axis position, so I added the y pos variable, but I think we should rename it to something like distance. So attribute triangle float variable at distance equals to distance between current point position to the center point, and center here is obviously 0, 0, 0. So we get our distance, and right now we can use it to colorize. How do we get the distance? It's pretty easy. We go here into the geometry spreadsheet, and here you can see all the parameters, and we go and find our distance, and we see that if we grab and double click it, we see that it starts from 0.47 till 0.56. So what we can do here is go grab a color attribute, obviously it should be distance, and we can visualize that. Now we see that in this case we go from the kind of light gray to green, and we see that parts that are far away from center are colored into green. For this color, I'm actually colorizing the particles from white to red, and obviously we want distance, so here we are. And let me quickly go through this slow motion thing here, and then I will show you the redshift part and other coloring options. And this is the thing that I found from the guys that did this Lenovo laptop, which I credited in the previous video. That's their idea. So about these time shift nodes, obviously we can just drop a time warp, which in my case is evaluation mode set by speed, and speed is set to 0.3, and output frame is from 1 to 300. Because we simulated 120 frames, we actually can go from 1 to 360 if we multiply 120 by 3. But yeah, in my case it's just these frames. Alright, so don't forget that here we don't have any particle ID attributes, so we actually don't need interpolate between input frames. For these two, as I said in the previous tutorial, one time shift is basically an offset for X frames. In my case, it's 30 frames. Second time shift is just your regular time shift, which will give you exact frame. Then we add a rest node, and then we plug all of that into the blend shapes, and then we can blend between these states. In my case, I'm blending it by 0.325, but you can see that you can blend absolutely differently. More on that, you can try doing two problem solvers or two file caches with different parameters of the noise, and then you can also blend two of these. So now you can see that as the time goes, we have these blank spots, which are absolutely okay, and there's a reason why they are there. But we can do something called point replicate. In this case, I'm exchanging 1 point to 5 points. So if we have here 259,000, here we will have 1,298,000. So here a few things. Attributes should be checked copy source attributes because we want to copy our color and actually we want to copy our P scale. For the noise, I just take this add noise button. For the shape set to sphere because it looks better than the box. For the quantity, yep, 5. You can add 20 or hundreds, but just be aware that it's quite a resource heavy operation here. So when I check point replicate, and in my case I also needed to update the uniform scale to 5 because if it was 1, it basically spawning them on the same position, and because of our really dense mesh we want to set them to something like 5. Really dense particle separation, sorry. So yeah, now we have more of these particles here, frame 60 to frame 270. Here is a crucial thing that you should kind of add some sort of frame padding because I really didn't like this. Let me remove the point replicate. I really don't like these first frames where it kind of starts. As in the previous tutorial, I wanted to be like pretty consistent, so that's why here I'm also rendering from frame 60 till frame 270. And that's it for the setup. Let me open up the Redshift. I want to show you a few cool things about this. So let's start our render. Let's go and check camera 1 and let's zoom out a bit. So as you can see, if you're using point replicate, it's a lot more geometry, so you gotta adjust how the light is perceived here. So I think, yeah, you can really feel the difference between when we enable the point replicate, here you can see it, and without it. I still don't know which result I liked better, but yeah, it's handy node when you want to fill gaps or just like add more particles without actually simulating more particles. So here, let's say we have our attribute distance and we can try these presets in colors. So let's say we want to try Inferno, which actually looks really cool. We can try Plasma, we can try Magma, we can go and try just a sand, for example. We can also try this Twilight, which I thought was really cool, and Twilight Shifted, which is kind of like inverse the Twilight, and Viridis, and that's not that cool, but yeah, of course the White Water. So really many possibilities to create something cool. So I think that's it. For today, guys. I really hope you enjoyed this quick little addition to the previous tutorial. I might do these in future for other tutorials that I'm doing. And quick reminder, all of you are very welcome in our Discord channel. I was doing this setup live today in the morning. Sadly, at some point Discord live wasn't working, and that was like global Discord fault, not mine, but still, I have a huge list of tutorials to do. So there's definitely many more new stuff coming, and I will be doing these every week, so stay tuned. Bye!